Hey guys, welcome back. So what we're looking at today is 4.6, sign on the dotted line. So for this first part here, identifying extraneous solutions below is the work done to solve a rational equation. The problem has been worked correctly. Explain why the solution or why the equation only has one solution. So if we look at this according to their work, it should be that x equals 2 or x equals -1. But if we substitute each of those in up here, what's going to happen when we plug in 2 for x in this equation here, or in this equation here? It's going to make the denominator 0, so it can't exist there. So it's an extra solution because it makes x equals 2 makes denominator equal to 0, which can never happen. We can never have a denominator that is 0. All right. The next section, substitute the given numbers into the given equation. Identify which are actual solutions and which, if any, are extraneous solutions. So for number 2, plugging in -1 and 5/2 into our equation. So -2 times -1 is going to give us -2 plus 1 is -1. That works. We're good. For 5/2, if we plug that in, 2 times 2.5 is going to give us 5. And then add 1 to it. We're still good. We're at 6. So both solutions work on A. So A equals -1, 5/2. No extraneous solutions. Now, with number 3, if we plug in 0 and 3, well, 0 squared is 0, minus 0 is 0. So d equals 0 is our extraneous solution because d can't equal 0. And then for 3, 3 squared is 9, minus 3 is 6, so that's good. And 3 minus 1 is 2, so 3 does work. So same idea as what you'll do on number 4. Now for 5 and 6, we want to solve these and watch for any extraneous solutions. So looking at our denominators, we need to have them have the same denominator. So for this one, we have x squared minus x, and we have x minus 1. So the nice thing here is all we need to do is multiply the second fraction by x. So we end up with 1 over x squared minus x over x squared minus x. And, oh, well, sorry, I forgot about the 2 on the other side. And multiplied by 2. So 2 out there. 2 out there. I know it's really hard to see, equals. Now here is where it's a little more complicated. We have to multiply x squared minus x to this fraction, and then it'll be over 2 times x squared minus x. So whatever we do to one side of the equal sign, we have to do to the other side as well. So now, because all the denominators are the same, we can ignore them. So we have 2 minus 2x equals x squared minus x. Add the 2x over. We end up with 2 equals x squared minus x. Subtract the 2, so we have 0 equals x squared minus x minus 2. Factor this. We can have a -2 and a +1. We'll multiply to give us -2 and add to give us -1. So that means our two solutions are x equals 2 and -1. And so then if we look at plugging those in, well, -1 minus 1, that'll give us -2, so that's okay. -1 squared is +1 minus -1, so really +1 would be 2, so that's all good. If we plug 2 in, 2 squared is 4, 4 minus 2 is 2, and 2 minus 1 is 1. So both solutions work for this. So same idea when you're doing number 6. All right, the next section. So predicting and stretching rational functions. So or sketching, sorry. Find the vertical asymptote, horizontal or slant asymptote, and intercepts. Then sketch the graph, not use any technology. So we'll look at various stretches here as well as graphing these out. So stretch is your keyword for this lesson. Stretch. All right, so for this first one, our vertical asymptote, remember we use the denominator for that. So set the denominator equal to 0. We'd have negative 2x equals 6. Divide by negative 2, so x equals negative 3 is our vertical asymptote. So I'm going to draw a line, kind of sort of dashed line to represent that asymptote there. Now, the horizontal or slant asymptote, well, looking at this, we have, trying to take and simplify this, we're going to have a horizontal asymptote, and it's going to be at y equals 1/2. Negative 1/2, sorry. Negative there. Which, too hard to draw on here, but it'll be just below the x-axis. And then the intercepts will be at 0 and negative 2/3 and negative 4, 0. So 0, negative 2/3, and negative 4, 0. So our graph will look something like such. Yeah. Sorry, line's a little off there. So something like this. So when in doubt, as you know, plug in x values to get your y values to help you graph this. But that's what you're looking at here for these. The last section, exploring linear equations. What value of k in the equation kx plus 10 equals 6y would give a line with a slope of negative 3? So what can we divide by 6 to get negative 3? Well, that would be negative 18. What value of k in the equation kx minus 12 equals negative 15y would give a line with a slope of 5, or with 2/5? So we want to be able to divide each of these to reduce it down. Looks like dividing by a negative, or a 3. So what divided by 3 is 2? That'd be negative 6. So k equals negative 6. The standard form of a linear equation is ax plus by equals c. Write this equation in slope-intercept form. What is the slope? What is the y-intercept? So if we rearrange this, we'd be taking and subtracting the ax. So we have, let me do it up here, so space. So we have ax plus by equals c. We subtract the ax, subtract the ax. So we have by equals negative ax plus c. It's supposed to be an a. We divide by b. So we'd end up with y equals negative a over bx plus c over b. So there's our answer for slope-intercept form. Y equals negative a over bx plus c over b. So the slope is negative a over b, and the y-intercept is c over b. All right. If b is the y-intercept of a linear function whose graph has a slope m, then y equals mx plus b describes the line. Below is an incomplete justification of this statement. Fill in the missing information. So m equals y2 minus y1 over x2 minus x1. That's the slope formula. M equals y minus b over x minus 0. By definition, if b is the y-intercept, then 0b is a point on the line. Y comma x is any other point on the line. 3, m equals y minus b over x. Reason is because x minus 0 equals just x. So then m times what equals y minus b, based on the multiplication property of equality. That would be x, and then mx plus b equals y, or y equals mx plus b, what tells us we can say it either way around, the addition property of equality. Addition property of equality. And there's our answer. All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.